In this session, I'm going to talk about clustering, which is a part of unsupervised learning, right? We have looked at different kinds of supervised learning techniques till now. Under the supervised learning, we said there could be classification problems, there could be numerical predictions, and in some cases, we can have some kind of algorithms which can cater to both of them. Under the classification, we have looked at Naive Bayes, the nearest neighbor algorithm. We have looked at decision trees. We have also looked at classification rules. So these are the ones which cater to the classification problems. Similarly, we have looked at the linear regressions. We looked at regression trees, model trees, which are falling under the numerical prediction. Similarly, we also had the support vector machines as well as neural networks, which can be categorized, which can be utilized for both classification as well as the numerical prediction kind of objectives as well. So all these are supervised learning. In the unsupervised learning, we said there are two major aspects. One is clustering or grouping the data. The other one is pattern recognition. So two major aspects as a part of unsupervised learning. So out of that, right now I would be looking at the clustering aspect, where there is no target because it's a unsupervised learning. We are trying to identify the similarities between the groups, and based on that we are trying to cluster the data based on various features. Cluster as a word itself is group. So we are trying to find the natural groupings in the data. That is what is the objective of clustering. So we will try to understand what do we mean by clustering here. As a machine learning task, how do we treat clustering? One of the oldest and the most powerful algorithms, one of the very old kind of algorithms pioneers in terms of clustering is the k-means algorithm. So let's see how do we really use k-means clustering algorithm for doing the clustering of the data. And so to say which variables are close, or to see which examples are closer and which of them are farther from each other, there is some level of distance measurement that we talk of. So how do we use that distance to really assign a variable to a particular cluster versus assigning it to some other cluster? So to whichever cluster a particular example is closer, it would be assigned to that particular cluster. And after that, there is again a revision of the process. After once the whole assignment is done, there is a revision of the process also that occurs. So we will have to see how that assignment and reassignment typically occur. How do I really decide on how many clusters I should go with? And once I do all this aspect, I'll take an example. Once we have a theoretical understanding of the whole process, we can take a data set, and on that data set we can very well perform a clustering process. So as it is very clear, it is an unsupervised machine learning. So there is no prediction aspect. I am not doing a classification or any kind of prediction here. So it's an unsupervised learning. So we are dividing the data into clusters here. The whole data that is supplied based on the various features associated with the data, we are grouping the data into different clusters. So there is no prediction aspect here in the process. It is primarily used for knowledge discovery. I am trying to come out with some kind of a new pattern in the data. So there is no relationship between the dependent variable and the independent variables here. because there is nothing called a dependent variable. So there is no relationship between the dependent and the independent here. All the variables are taken together, and depending on how close they are or how farther they are from each other, they are grouped into the appropriate category. So we are trying to form natural grouping rather than looking at the groups of the dependent variables. We are trying to see the natural groupings within the data, right? And the main fundamental behind this clustering aspect is the records that are there, the examples that are there within the cluster, right? The examples that are there. Now let's say here this is the whole data, right? Now I'm talking about one cluster, two clusters, three clusters. So the examples that are there within the cluster, they all should be very much similar in many aspects. Whereas if I'm talking about the elements between the clusters, they should be very much different from each other. So within this cluster, all of them should be more or less similar. Within this cluster, all of them should be more or less similar. But between these two clusters, the characteristics of the element should be very much different. So all those which are having similar kind of characteristics, which are more or less related kind of elements, related kind of records, related kind of examples, I am placing them together and I am separating them from the other groups of examples. So that is what is going to happen as a part of the clustering process. Coming to the major applications, yes, the marketing guys use them very heavily. They do the segmentation of the customers. So based on the buying patterns, I want to group the customers. Depending on the demographics, I want to group the customers, so that once I am able to bifurcate my total customers into different groups, I can target a particular campaign to particular group of customers. So that's how we can very well use the concept of clustering. Even if there are some anomalous behaviors, right, all the majority of the elements are going into one or two clusters, but one or two abnormal data points, they are going into some other clusters. So we are able to identify the abnormalities in the data, those records which are quite different from the rest, and we can very well try to correct those abnormalities and anomalous behavior in the data. And if I have large data set with huge number of values, so we can very well group all those features and we can very well reduce the number of categories that are there for this particular data. So even if for reduction, the whole dimension reduction, the data reduction, I can very well use the cluster analysis also. So generally when I have fully diverse and varied data, and where my objective is to reduce all that data into a few groups, group the data in such a way that overall this whole data of few thousands or few millions of records are coming down into a countable 5 to 10 groups of data altogether. So this is where the clustering will have a major role to play. But once the clusters are formed, I have to create a meaning. Cluster in itself does not have any kind of a meaning. So I have to really see what is the meaning that I can create to this cluster. How do I give a name to this particular cluster? What is the major differentiator of cluster 1 and cluster 2? In what aspects is cluster 1 different from cluster 2? So I have to give the meaning to it. So I have to really see that whatever the clusters that are getting formed, they have some kind of business meaning or functional meaning